Hello students, welcome to Rise the Perfect Guide. This is Ajay Jumli, your chemistry educator. Today we are going to learn about one of the most important trick from chemical bonding. So from chemical bonding, we are going to learn about trick to find the hybridization, which is one of the important topic for JEE, NEET and EAMCET entrance examination. So listen carefully. In this trick, we have few simple steps. If you will follow these steps, you can easily answer the questions which is related to hybridization. Okay, the first step is, in a given molecule, write number of valence electrons on central atom. First of all, what we need to do, we have to find number of valence electrons present on the central atom. Okay, for example, beryllium is given as a central atom. What we need to write? We need to write two valence electrons, because in beryllium two valence electrons are present. As we know that this is very basic thing and very simple thing. Okay, now here I have given examples also. If boron given as a central atom, three valence electrons are present. If carbon is given, four. If nitrogen is given, five valence electrons are present. If oxygen is given as a central atom, then six valence electrons are present, up to so on. Here I have given simple examples. Okay, this is the step number one. And what is the step number two? This is very simple. Step number two, we have to write number of monovalent atoms. Sir, tell me what is mean by monovalent atoms? What are the example for the monovalent atoms? Look at here: hydrogen, fluorine, chlorine, bromine, and iodine. These are the example for the monovalent atoms. Very simple. If you will see in a given molecule, hydrogen, fluorine, chlorine, bromine, iodine, you just write how many number of hydrogens are present, how many number of chlorines are present, how many number of bromines are present, how many number of hydrogens are present. We have to write. That's it. Very simple. And step number three, if positively charged species is present, then what we need to do, we have to do minus. If plus 1 is present, what we need to do, we need to write minus 1. Very simple. If plus 100 is present, what we need to do, we need to write minus 100. Very simple. If plus 3 is present, we need to do minus 3. Very simple. Okay, in a fourth step, what we need to do, if negatively charged species is there, we have to do plus. For example, if minus 1 is there, we need to write plus 1. If minus 2 is there, we need to write plus 2. Very simple. If minus 100 is there, we need to write plus 100. Very simple, Nana. If positive charge is there on the given molecule, we need to do minus. If negative charge is there on a given molecule, we need to do plus. Very simple. Okay. The next fifth step and last step. So we have to divide this value with 2. We have to divide this value with 2. So let me explain by giving one formula. Hybridization is denoted with Z. Z is equal to, as I said that in first step, what we need to do, we need to write number of valence electrons on central atom. Okay. Then we need to add plus monovalent atoms. If hydrogen, chlorine, bromine, iodine is present, we have to add those monovalent atoms. If not present, we no need to add. Okay, then if positively charged species are present, we need to do minus. If negatively charged species is present, we need to do plus. Very simple. After that, we have to divide with 2. So we have to divide with 2. Okay, we have to divide with 2. This is the simple formula. And if we will do this calculation, you will get one value here. If this value, if you will get this value is 2, then sp hybridization. Okay, hybridization is sp. If you will get 3, that is sp2 hybridization. If you will get 4, that is sp3. If you will get 5, that is sp3d. And if you will get 6, sp3d2. If you will get 7, sp3d3. And here I have given geometry also. If for sp hybridization, what is the geometry? Linear for sp2, trigonal planar for sp3, what tetrahedral for sp3d, trigonal bipyramidal. And for sp3d2, octahedral. For sp3d3, pentagonal bipyramidal. Okay, let me take one example. Okay, here I took example, and this example question is asked in NEET 2016. Okay, now basically this is a previous year question, and this question is also asked in AP EAMCET and TS and EAMCET entrance exam also. Okay, so this is very important. Let me solve one beautiful question, then you will get one idea. Here I took one example from NEET 2016 previous year question. This is one of the important previous year question. These types of questions generally we will see in JEE and NEET, and as well as EAMCET entrance exams also. Okay, the hybridization of the atomic orbitals of nitrogen, NO2 positive, NO3 negative, and NH4 positive are respectively. Here I did not give, here I am not given any options here without, here I am not given any options, because without knowing answer, you can easily do. So what is the first molecule they have given? NO2 positive. Let us find the hybridization of NO2 positive. So first of all, what we need to do? We have to find the number of valence electrons on central atom. Here nitrogen is a central atom. So in nitrogen, how many valence electrons are present? Tell me how many valence electrons are present. Here I have given example also. In nitrogen, 5 valence electrons are present. How many valence electrons are present? 5. So we have to write 5 plus. If any monovalent atom is there, what we have to do? We have to add. But here, no monovalent atoms are present here. Here there is no hydrogen, there is no chlorine, there is no bromine, there is no iodine. Okay, we no need to mention monovalent atoms. Next, what we need to do? If positively charged species is there, we need to do minus. If positively charged species is there, we need to do minus. If negatively charged species is there, we have to do plus. Here positively charged species is present, so we need to do minus. So plus means what? Plus 1 is, plus 1 charge is there, so we have to do minus 1 by 2. Here there is no negatively charged species, we no need to add. Now I will explain the hybridization by taking one beautiful question, then you will understand. Basically this type of questions will going to ask in NEET and JEE entrance exams also, and as well as EAMCET and AP EAMCET and TS EAMCET entrance exams also. So this question is asked in NEET 2016. Okay, so what is the question? The hybridization of atomic orbitals of nitrogen, NO2 positive, NO3 negative, NH4 positive are respectively. Okay, this is the question. So here I have not given any options, because without knowing options, we can easily do the answer. Okay, so first of all, we need to find the hybridization of NO2 positive. Okay, let us find the hybridization of NO2 positive. NO2 positive. So first of all, what we need to do? We need to write number of valence electrons on central atom. Here nitrogen is a central atom. In nitrogen, how many number of valence electrons are present? 5. Okay, here I have given simple examples also. This is a basic thing. You can also, you can directly write the number of valence electrons, because these are very basic things, 9th and 10th class things. Okay, so we need to write number of valence electrons. How many valence electrons are present in nitrogen? 5. Okay, then what we need to do? We have to add number of monovalence atoms. So what are the example for monovalent atoms? Hydrogen, fluorine, chlorine, bromine, iodine. So there is no hydrogen, there is no fluorine, there is no chlorine, there is no bromine. So monovalent atoms are absent in this molecule, so we no need to mention monovalent atoms. So next, what we need to do? If positively charged species is there, we need to do minus. If negatively charged species is there, we need to do positive. Look at here. Here positively charged species is present, so plus means plus 1 is there. Okay, so we need to do minus. So 5 minus 1 by, so 2. 5 minus 1 by 2. So after that one, what we need to do? We need to divide with 2. Am I right? We need to divide with 2 now. So I have divided with 2. Okay. So what we will get answer? 5 minus 1 by 2 means 2 ones are 2 twos are. So we will get Z value 2. Z value 2 means what? SP hybridization. See, Z value 2 means SP hybridization. Next, so let us find the hybridization of NO3 negative. So here also nitrogen is a central atom. So how many valence electrons are present? 5. And there is no monovalent atoms. We no need to mention. And here there is no positively charged species. Only negatively charged species is there. Na? We need to do plus. Okay, negatively charged species is there, that we need to do plus. Okay, so minus means minus 1 is present, we have to do plus 1 by 2. Okay, 5 plus 1 means what? 6 by 2. 2 ones are 2 threes are. Okay, here we got Z value 3. That means what? It is having sp2 hybridization. Okay, it is having sp2 hybridization. Okay, NO3 having sp hybridization, NO3 minus having what? sp2 hybridization. Let us find the NH4 plus NH4 plus hybridization. Here also nitrogen is a central atom. So nitrogen is a central atom. So that means number of valence electrons how much? 5. And here see, monovalent atoms are present. Here 4 hydrogen atoms are present. So if monovalent atoms are present, what we need to do? We need to add. So plus 4. So number of hydrogen, how many number of hydrogens are present? 4. That means I mentioned 4 here. Next, positive charge is there. We need to do negative. So plus means we have to do minus 1 by 2. 5 plus 4 is equal how much? 9 minus 1 is equal how much? 8. 8 by 2. 2 ones are 2 fours are. So Z value how much we got? 4. If Z value is 4, what is the hybridization? sp3 hybridization. Okay. So NH4 positive having sp3 hybridization. So first one having sp hybridization, second one having sp2, third one having what? sp3 hybridization. So we can also write geometry also for sp hybridization, linear geometry for sp2, trigonal planar, and for sp3 tetrahedral geometry. Okay, so in this simple way we can find the hybridization. So now I will give homework. So just find the hybridization for SO3 and SO2 molecules. Okay, thank you so much all of you, all the very best, and bye bye.